Hello, Professor. This is Arthur Bedford. I will be making this as a video on YouTube because I have horrible Wi-Fi, so I will be just telling you, I'll be having you follow along with my PowerPoint slides. You'll have the slides pulled up, and I'll just tell you which slide to go to. I just feel like this would be the easiest for uploading. So let's get started. So my organism that I am reporting on is the honey fungus. It's Armillaria Mellea, and this mushroom isn't really it's not really amongst the ones that we would typically think of in terms of medicinal uses. Like everyone knows about reishi, shiitake, lion's mane, cordyceps, turkey tail. Those are very common in their uses due to their medicinal values. The honey fungus, though, I chose this one because this is very prolific around here in the UP. I've found if you go out to Presque Isle around, I'd say mid-fall, maybe a little earlier, you find these clusters of these everywhere. And even when they're not growing, you can find these black web-like structures located on fallen tree stumps. These black web-like structures are rhizomorphs, and they're indication of the root rot the indication of the presence of the fungus that has caused the root rot of that tree. Now, I first started looking into this because of the constituents that were discovered off of this mushroom. Because originally I was looking for alkaloids that could be extracted from Amanita muscaria, and came across some of these. Well, not alkaloids, these aren't going to be alkaloids, but came across these molecules as well that could be used for medical application. So on to the next slide. So biology, right? So Armillaria Mellea, the honey fungus, gets its name from the golden color that the caps have when you see them in the wild. And the main thing about this fungus is it has a parasitic relationship and engages in a parasitic relationship with its host. The host usually being any type of wooded trees, especially in old growth forests and such, or also it's very prevalent in places that have just been cleared. The area has just been disturbed. Spreading is very common through that way as well. So what's distinct about this mushroom is that you'll find it grown in clusters, all connected at the same base, very multiple clusters. I'd say, I've seen clusters with, 7, 8, stems and caps, just all in just one little cluster. It is edible. It is safe to eat, even though it has this, even though it acts as a parasite on trees, it's safe for us. And then, like I said, so once the fruited body is visible, the tree is gone. It's already been fully infected and dead in order for that to have produced a fruited body. And when I say that, I mean, Armillaria Mellea. On to the next slide, onto the chemistry bit. So this is the reason why I chose, this molecule on the left side of my slide, armyl, is the reason why I chose this specific organism, right? And the reason I found fascinated just because it has at locations 1 and 2 at the top left of the molecule, you have this carbonyl group, this carbon double bonded to an oxygen, right, with an adjacent unsaturated bond between carbons 2 and 4, right? So this in chemistry, again, I'm sorry, I don't know if you have any chemistry background, so I must assume you do due to the lectures, but we're just going to go off now. So it's a Michael acceptor, right? And those are very reactive functional groups, or parts of the molecule. They're very reactive, and so I originally anticipate this. It's most of its activity, I believe, coming from this Michael acceptor. This Michael acceptor that is connected to the cyclobutane ring. And just because I was talking to my teacher, and cyclobutane rings don't really occur too much in nature, just because as you know, like what you learn in basic chemistry is that 3, 5, and 6 membered rings are favored in nature, but this forms a 4-membered ring, which I find to be quite fascinating. Now, and the reason why I think this little section right here of this entire molecule is what matters is because this bottom benzene ring with all these substituents is called orsolinic acid, and on its own, orsolinic acid does not have cytotoxic effects on cancerous cell lines, or really antimicrobial effects or antioxidative effects. So it is really the entire molecule that is necessary, and I believe that it really does stem from this Michael acceptor and the cyclobutane ring. So they found, in a study they found aqueous extracts of Armillaria Mellea found that the extracts prevented oxidation and DNA damage neurologically within the brain, and what's even more so it helped neurologically, right? But even more specifically of this chemical study, so they found that extracts can decrease depression within their participants of their studies. They found that depression symptoms were decreased through the regulating of the HPA axis. And as you know, there are studies that have shown that the expression of corticosterone and adrenocorticotropic hormone and corticotrophin releasing hormone in the HPA axis changes during depression, right? An overactive HPA axis can also reduce, dysfunction in this can reduce the production of neurotransmitter and neurotropic factors, which, ultimately leads to depression. So they have found that this extract decreases depression through through regulating our inflammatory cycles. And what's also big is this. So this molecule itself is known as a protoylidane, and protoylidanes are what have these effects that I just described. And there are a high variety of these there are a high variety of these within the organism that help regulate our inflammatory processes. And we're going to go, actually, before I go on to the next, so I looked at a study talking about the cytotoxicity, because most papers you find on Armillaria or sesquiterpene aryl esters, or just Armillaria Mellea in general, you'll find a lot of antimicrobial, antioxidative properties of papers that are, corroborate these properties, but not much on the cytotoxic effects against cancerous cell lines. So I found one that specifically looked at that, and so they found that this molecule, specifically Armillaria, only 10 micromolars was necessary to induce apoptosis among cancerous cell lines, which is significant because that's not a lot of amount. It's not a very high amount. 10 micromolars is, it's just a very minimal amount, especially when an extract from a cultured mycelial broth of Armillaria Mellea yields 3 milligrams per liter of Armillaria, right? So 3 milligrams per liter versus 10 micromolar for effectiveness, against cancer, that seems pretty good to me. So that's why I wanted to look at this molecule eventually within my capstone 420 course, I could try to look at the synthesis of this molecule for a new novel drug, or cancer drug. All right, on to the next slide. How to use. So Armillaria Mellea can be actually grown at home. You can get spawn bags with wood. You can get like wood pellets, vermiculite. Yeah, basically that. Yeah, it's a saprophytic fungi, so it prefers the you grab a wood that get a wood that easily decays, and you can and the best method would be to use a liquid culture, which is what I have pictured here at the top right of the how to use slide. So a liquid culture is a liquid broth of mycelia, which mycelia is the main body of the mushroom. So this liquid mycelia would grow onto your substrate, and then give it necessary light, water, and then you could grow these mushrooms. You can culture these mushrooms yourself, but you can grow them and eat them yourself. But like for these studies that I've been referring to, they cultured their own mycelia on agar dish, or just using this straight liquid culture, and went from there. So most common, I didn't see any tinctures or just extracts, or I didn't see any sort of products listed in that way. Most commonly, if you go online shopping for this, you'll see like spawn plugs, which are like little wooden dowels that have been inoculated with mycelia that you can inject into a tree. So if you have like trees on your yard that you'd like to grow these mushrooms, you can just drill a hole, put in the wooden dowel, cover it with something to seal, kind of like a Vaseline type, and then eventually they will infect the rest of the tree. Although you might not want to, you want to use like downed logs already, just because obviously this induces root rot. Oh, did I say that? Okay, well, the parasitic relationship between this and between Armillaria Mellea and trees can be seen through root rot, right? That is the main way of death that trees experience once infected by this fungus. So you don't eat the stems, but you can eat the caps. You clean them, kind of like peel off the top, give them a good cleaning, and then you're good to go. But if you're harvesting these wild, you want to make sure that you harvest them before the veil and the cap has fully opened, because I was told by my teacher that once it's already opened and it gets a little older, it starts accumulating many microorganisms that they're just a part of its breakdown, because once it gets to a point, they decay very fast. They do not have a long shelf life. Biggest thing about this is when cooking, it is slightly bitter when fresh, but then slightly sweet when cooked. So that's why it's been utilized culinary facets. And then after that is just my references. So thank you for your time. I think personally, if I were to grow this or go out and harvest it myself, again, you want to do it right when it kind of looks at, if you go back to the biology slide right here, before they're really opening, that's the best time. Before they really fully open, the best time to harvest them. They say they have a meaty texture, so it's a good substitute for like chicken and stuff. I would really like to use this organism and these molecules. I'd love to prepare my own extract and test them for safety, and then synthesis of arnimayil, because if I can devise the synthesis of this compound and do it for cheap, then that's heck. I think next is clinical trials, so we'll see. Thank you for your time.